Hello and welcome back. In this video, we are going to learn about domain and range of functions. Domain of a function is the set of inputs or the set of pre-images, while range is the set of outputs or the set of images in a function. Let me explain it with the help of a mapping diagram of a function f defined from a set A to set B. We can see set A have elements 1, 2, 3, 4, 5, while set B have elements 1, 4, 6, 9, 16, 20 and 25. We said domain was the set of inputs and all set A is the set of inputs because that is the criteria of a function that all elements of all elements of first set must map. So the domain of function will always equal to the first set. That's why domain of function f written as df equals 1, 2, 3, 4 and 5 elements. Now coming to the range of the function. We said range of a function is the set of outputs or the set of pre-images or the set of images. In set B we can see 1 is the image of 1, 4 is image of 2, next 9 is the image of 3, 16 is image of 4 while 25 is image of 5. Coming to the two elements 6 and 20, they do not have a pre-image, so they cannot be considered the images. That's why they will not be part of the range set. The range set will only contain 1, 4, 9, 16 and 25. They are still the members of set B, and set B is known as codomain, but from now on we will only discuss domain and range. Codomain will not be the part of discussion from now on. So the range of set will only contain the images, those elements of B which are not images of any element, they will not be the part of range. Coming to the question where he said find domain and range of the given function g from set x to set y. Now we can see the set x consists of elements 0, 2, 4, 6, 8 and 10, while the set y consists of elements 1, 3, 5, 7, 9, 11 and 13. We know the domain of a function d, g being the function, will equal to the first set. So it will be 0, 2, 4, 6, 8 and 10, and range of the function being the set of images will consist of elements 3, 5, 7, 9, 11 and 13. Once again, 1 will not be the part of set range because 1 is not considered an image because it do not have a pre-image. So that is range of the function g. Now coming to the domain and range of algebraic functions. Domain is the set of values for which given function is defined and real valued. Now defined mean it should not be undefined, it should not be infinity, and we know where is a function infinity when there is a 0 in the denominator, so it will be undefined over there. And real valued mean that it should not be complex. And what are the complex valued functions? Those functions where negative numbers appear in the square root, like square root of -2 is not real valued, square root of -4 is not real valued, etc, etc. Any negative number under a square root will not be considered real valued. So the set of values for which a function is not undefined and not complex is domain, while what is the range? Range is a set of all possible outputs of the function subjected to given domain, because domain can vary with the functions, so range can also change with the domain. For given functions f of x equals 1 upon x and g of x given as square root of x, we are to find domain of the function and range of the function. First, considering f of x, domain of the function, we know that where the function will be undefined when the denominator is 0, and if denominator is x, so it cannot be 0. We say that domain of the function is all real numbers except x is equal to 0. It cannot be 0 in the denominator because it will turn into an undefined function. So the domain of function is all real numbers. We can put any number in this function except that of 0, or we can directly write it as x not equal to 0. That will be enough. All right. And talking about the range of the function, this function will give us all real numbers. Its input may be all real numbers except f of x is equal to 0. And why it cannot be 0? Because a fraction is only 0 when the numerator is 0, while here we can see the numerator is 1, so it cannot be 0 definitely. That's why f of x cannot be 0. So we wrote all real numbers except f of x is equal to 0. That was the domain and range of function f. Now let's consider the domain and range of function g. The g of x function was given as square root of x. Now, as we have earlier seen that we cannot put negative numbers in the square root. So negative numbers will not be the part of domain of function g. That's why we wrote domain of function g is x greater equal to 0. Only 0 and greater numbers can be plugged in the function g. That is why the domain is x greater equal to 0. While talking about the range of function, we again stated that range of the function can be g of x greater equal to 0. Range cannot be negative. While earlier we learned that the square root of 4 is equal to plus minus 2. But in functions, we do not say that because it means that 4 maps onto two elements, plus 2 and minus 2, which actually violates the definition of a function that one element should not have more than one image. So that's why we only take the positive value of the function. That's why the range of function is only positive. G of x is only greater equal to 0. Otherwise, we know that square root can have negative values. We have been discussing it in the algebra, but in functions, we will only take one of the values, and that is the positive one. Now we are given a question that find domain and range of each of the following function. The first function f of x is given in the form of a linear expression 5x minus 1, and in case of linear expressions, the domain of function and the range of function both are all real numbers. All real numbers are the set of real numbers. All right, so domain and range of the function f are both same. Now coming to the second function, g of x equals 3x divided by x minus 2. That is a fraction, and we know that fraction can be undefined if the denominator becomes 0. X minus 2, if it is 0, then x will be definitely 2. So we can directly say that this function will be undefined at x is equal to 2. So that cannot be the part of input. That's why the domain of function g will be all real numbers except x is equal to 2, or we can directly say that x not equal to 2. That is its domain. Now coming to the range of function, in case of the fraction, the range of function only exclude the value which is the ratio of the coefficient of the numerator and the denominator. We can see that the numerator is 3 while the denominator, the coefficient of x, is 1. So 3 cannot be the part of range of the function. That's why we'll write it as all real values. They are all real numbers except it was g of x, except g of x equals 3, or directly say that g of x cannot be 3. Once again, in case of fractions, if we have variables on both numerator and denominator, then the ratio of their coefficients is excluded from their range. Now coming to C part, where he gave us a function h of x defined by square root of x plus 3, and we have already dealt with a square root function. Here the domain of function h will be given as, we can see that there cannot be a negative number under a square root, so that's why we will write it as x plus 3 greater equal to 0. It can be 0 or it can be greater than 0, but it cannot be less than 0. So it implies that x is greater equal to minus 3. That is the domain of function h. So it will be written as x greater equal to minus 3. We can put minus 3, minus 2, minus 1 and any greater value, but not less than minus 3. So that is the domain of function. And we already know about the range of square root function, that is considered only positive number. So I'll write it as h of x is greater equal to 0, because we cannot take the negative values of this function h of x. Now let's talk about the functions with restricted domains. We can see some functions with where the domain is restricted, like we example the function is given as f of x equals x square, where 0 less than equal to x less than equal to 5. This is known as the restricted domain. All right, so that will be the domain of function. So as the domain is restricted, the range will also change with this function. Okay, so first we put the lowest value of x in the function, that will be f of 0, and we can see that it will be square of 0, that is 0. Then we put the terminal value of the function f of 5, and the square of 5 is 25. That is why we can see that the range of function is between 0 and 25. I will write it as 0 less than equal to f of x less than equal to 25, because the function was f of x. Now let's come to the question. Find range of the following functions. The first one is f of x equals 3x plus 1, where 0 less than equal to x less than 15. Once again we have domain. This is known as the domain of function, the restricted one, while we are to find the range of function subjected to this domain. So range of function f will be, now first let's put the values of domain and then we will get the range. First put the left hand side value 0 in the function. It will become 3 times 0 plus 1, and that results in 1. Then we put the right terminal value, which is 15, and it will become 3 times 15 plus 1 equals 45, plus 1 will be 46. So that are the two terminal values, and it will be written as 1 less than equal to, the function was f of x, and then it was only less than, right? That is why it will be written only less, and its value is 46. So that is the range of the function given above, subjected to given domain. Coming to the next part, in which he said the function g of x is defined as square root of x, where domain is once again given as 0 less than equal to x less than equal to 100. That is domain of function g. We have to find the range of function. Once again we have to first plug in the terminal values of the domain, like the left terminal value is 0, and it will become the square root of 0, which is once again 0, and the right terminal value is 100, so it will be g of 100, the square root of 100, that comes 10. So the range of function g will now become 0 less than equal to g of x less than equal to 10, because we can see that the inequalities are both less than equal to. So that is known as the range of function. Now here we have some question for the self-assessment. I will like if you pause the video for a minute, try this question on your own, and then see the answers below.